Beautiful talk. Of course, we all want to have coffee already, but please hold a while longer. So I'm Hans van Ditmars, and I will give a talk on some matters relating to awareness. And I have to place this microphone a bit lower because otherwise I hear too much of myself. So this is joint work with Tim French, who is not here, Fernando Velasquez, who is over there in the audience, and who will talk himself at other occasions during this week, and Yi Wang, who was supposed to be here, but unfortunately didn't make it because of unresolvable visa problems at the last minute. But, okay, I'm here. A great advantage in presenting a talk on this topic was that Burkhard already gave his talk yesterday, which introduced up to the examples and the setting of the things I want to talk about here as well. So this is very helpful for my own presentation. And so the things that are written on here we have already seen. So the idea is that, well, we want to model knowledge and uncertainty, but there are some things of which you are not aware and some ways in which we can model this. And for me, this distinction is essentially between uncertainty and incompleteness. And awareness is then about incompleteness. And some of the works that appeared in that area, well, have been discussed. We can skip that. So what have we done here? Well, we have used this Fagan and Halpern setting of structures for awareness to derive some results about expressivity, bisimulation, and some, well, you might say some additional results in axiomatization not already achieved by those authors, and also apply these to settings wherein dynamics of awareness plays a role. What happens when agents become aware of something and how that changes what they can say about knowledge and awareness. Also, if they, you might say, reason about knowledge and awareness dynamics in a current state of information. And a crucial role in these discussions plays the notion of awareness by simulation. Well, if you see the word bisimulation, you think, oh, right, that must have to do with some computer science thing. It's indeed, you might say, it's the obvious notion of sameness of structures under these conditions, and in a way, it's a bit surprising that for me that it has not come up before as such as that proper notion. So to introduce this matter, let's go to the rock bottom example where there is a single agent and a single propositional variable p, and the agent I who is uncertain about the value of a variable p. Then you could observe that in the presence of other variables of which the agent is unaware, for example, a variable q, there are various ways wherein, given uncertainty about a variable p, the agent then later may be uncertain about p and q in a way you might say that is consistent with the current uncertainty about p. And below we see 4 of these different ways in which the agent can be, well, also certain or uncertain about the variable q in the presence of a p. And, well, p, I should have, p could say, stand about the uncertainty about coffee after this talk. By now I can pretty much surmise that there will be coffee after this talk, but I might be unaware of it that wine is not served after this talk, and most of you will also have been unaware of that, right? So, because it just didn't occur to you. In the morning, wine, yeah. If we look at the 4 bottom structures, then you can see that if we look at this one, well, there is still a not p here and a p there. So you can put a q here and a not q there, but that seems to be a, well, consistent extension of how we got here first. But there's nothing about having q both true here and there, because it's still the case that p is false here and p is true there. So that seems also to be, well, compatible with the uncertainty we already had. Or if you go here, well, there is one difference here, because this structure has 3 states, right? And this only 2. So how can a structure with 3 states be the same as a structure with 2 states? Well, here we have that q is true, here q is false, here Q is false, so this somehow represents uncertainty about Q, and it's still the case that at least on one occasion P is true and on two P is false, so it still also represents uncertainty about P. Well, what can you further observe? Well, if you look at this and this, then, well, these two states have the same property that P is false there, and that you can access a false P and a true P state from there. So they seem to have something in common that is represented by the single one on the left here. Well, here we are approaching the notion of similarity I want to sell here. And then you can make further observations about the fourth one. But the essential thing is that we can say that these four structures at the bottom, if you make the Q red, or in a sense, if you were to be unaware of that information, well, in a way, they're all the same as the top structure. Well, there's a notion in computer science that describes that. You can say that if you restrict yourself to the set of atomic variables P only, they're all bisimilar to the top one. But if you look at bisimilarity with respect to both variables, well, then actually it wouldn't be clear what you have to say about the top structure, but then there will be some difference. Okay. Just look at the red part. So, as these structures, well, they're examples of Kripke models with one additional aspect, the aspect indeed in the Fagan-Helpert structures, that we do not just have a set of propositional variables, but you split them into the aware and the unaware propositional variables. So, apart from the usual things as a set of states, accessibility relation, valuation, we also have a distinction that for each agent, capital N is a set of agent, and for each state, capital S is a set of states, well, we have a subset of the set of variables that stands for the variables of which the agent is aware in that state. And then the remaining variables are the variables of which the agent is unaware. Then used on that, you can also adapt the standard notion of bisimulation to, well, bisimulation given such aware and unaware variables. This is the intuitive way to do it, meaning intuitive as in wrong. What's the only difference in the structures that we now have? Well, apart from having a set of propositional variables in every state, well, we now have aware and unaware variables in every state. So we should not just require that the same variables are true in bisimilar states and the same variables are false in bisimilar states. Well, we should also require that the same variables, the agent is aware of the same variables in a bisimilar state except from the atoms requirement, it's such that for all atoms, two bisimilar states S prime should have the same true atoms. We should also require that in bisimilar states S and S prime, they have the same level of awareness of such variables. Done. Well, this works, but in fact you need something stronger, which I will give by example, not by this definition. But how do I adapt the definition? I'll watch at the thing that's going to change. This was the standard, you might say, intuitive way to do it. Now I go to the awareness bisimulation, and you do something in the definition of the relation in the accessible states. What do you do it? Well, you intersect it with the level of awareness in the accessible state. Example. And well, you use something for it, but let's look at this example. Even simpler example than the coffee and wine example. This is the example that will serve as the motivating example to demonstrate the results on expressivity and axiomatization. And actually, also in this example, I go to a level where the accessibility relations are no longer accessibility relations that have the properties for knowledge. But in a way, this does not matter because in a multi-agent setting, there's always some way to adapt such asymmetric examples into a multi-agent setting where you enforce the asymmetry by using different agents. So here we have 3 states. One in which P is true and the agent is aware of P. And the agent can access a state where P is true, but the agent is unaware of P. And the agent can access another state where P is also true, but where the agent is also unaware of P. This is another structure, same in all respects, except that P is false here. What do we expect now? Well, that the difference between P true and false here is supposed to be outside the level of awareness of the agent. This is what we want to express. How come? Well, here the agent is aware of P, but here the agent is unaware of P. You sort of want to express that if the agent is unaware of P somewhere, then that in some further state there is a difference in the value of P that should be irrelevant for the agent. So somehow we want these structures to be the same from the perspective of that agent I. Well, let us first check the definition of awareness by simulation that we have just seen. Well, I claim that these two models are P awareness by similar in this root state. Well, what was supposed to happen? They should have the same value for the aware atoms. Well, P is both true here. And in all accessible states, well, given the level of awareness of the agent, which is of P, well, then these accessible states should also be linked in this relation. Well, here again, they should have the same value of the atoms, P both true. They should have the same level of awareness of both atoms. Well, here, agent is unaware of P. And in all the accessible states, again, they should be that relation, but intersected with the current level of awareness of the agent, which is empty set, because the agent is unaware of P here. So therefore, in these root states, for the empty set of aware variables that excludes P, the value of the atoms should be the same. Well, that's true, because for no atom whatsoever, you can hold that, and it doesn't hurt anymore that the value of P is different here and there. So indeed, these structures should be the same. Well, they are P awareness by similar according to this definition, and they should indeed formalize the intuition that they are indistinguishable from the perspective of the agent. Okay, fine. So we are done, and then we can now have coffee, but no, there's a little problem. Let us look at logics to describe these structures. And in these logics, we have different epistemic notions, and we may have explicit knowledge, we may have, what did they say, explicit, right? We may have implicit knowledge, we may even have other notions. Imagine a language which has an operator for implicit knowledge and an operator for explicit knowledge. Now we look at the formula. The agent explicitly knows that he or she implicitly knows P. And we evaluate this formula, well, in the root of one of these structures. Well, explicit knowledge is defined by implicit knowledge and awareness. Well, then first we should see if the agent is aware of the formula implicitly know P. Yes, because P is a variable of which the agent is aware in the root state. So the agent is aware of this formula. And, well, and then we can check whether it is true. Well, then it is true here and false here. Because this says that if you do one step and another step, P should be true. And if we do that here, we do one step and we do another step, well, then P is false. So that should have not be there. So that seems bothersome, because we have structures that are bisimilar and that are not modally equivalent. That's not supposed to happen, right? What did we do wrong? Well, did we do something wrong? Well, what we did, of course, is we mixed explicit and implicit knowledge. And if you're reasoning about what an agent perspective, then this implicit thing should not be there somehow. Well, this has also been said before, but let us now see if we can make that precise. And the way to make this precise is that if you rule out that the box appears in these descriptions of the two structures, then indeed awareness by similarity implies modal equivalence. But then the question is there another notion of bisimulation such that that sort of modal equivalence indeed, well, has a relation to bisimulation? Yes, actually that was the standard notion of bisimulation that I presented at the first time. Okay, let me try to speed up. In the setting of the work presented at TARC here, we distinguish three epistemic notions. Two of those are the familiar implicit and explicit knowledge, but one of them is called speculative knowledge, which is in a way going back to an earlier proposal by Levesque. And here, let me point out the one difference between speculative knowledge and explicit knowledge. The idea of speculative knowledge is that you can speculate about, as an agent, reason, about variables of which you are unaware, but that simply do not have any meaning for you yet. Some sort of variables that do not have a meaning as a proposition yet. So in that sense, let us go to the example. You can, if we have a structure as on the top there that we have already seen before, where you are unaware of a variable q, and let's go to the middle of this, then we can indeed observe that agent I implicitly knows Q or not Q, some tautology. And we can also say that the agent speculatively knows Q or not Q, even being unaware of such a variable, but just because whatever that variable will be having as a meaning later, Q or not Q will always remain true. But of course we cannot say that E explicitly knows Q or not Q, because the agent is unaware of Q. And so there are some differences between between what we call here speculative and explicit knowledge that seem to be relevant in a setting of knowledge and awareness, where, and here I have to go indeed back to the previous slides, which I do not like in general, where this implicit and explicit knowledge are defined as usual, which I will not repeat here, but the speculative knowledge of something says that in all accessible states from a given state, the speculatively known proposition phi should hold in, well, subject to this relation, should hold in all, awareness indistinguishable states. So if you go to another state T, then if you take another structure with a root T prime that is indistinguishable from that T structure, well, with respect to the level of awareness of the agent, then phi should hold there. Here I will not give more explanations because then we will quickly run out of time. Now, what results have we achieved for these different notions of knowledge and awareness? Well, back to the other motivating example where we have this structure that should look the same from the perspective of the agent. But strangely enough has different logical properties if you mix explicit and explicit knowledge. Then the explanation for this is that, well, indeed, the models are not modally equivalent in the logic of implicit knowledge, where we use that explicit knowledge can be defined as implicit knowledge and awareness. But they are modally indistinguishable, they are modally equivalent in the logic of explicit knowledge. If you rule out the box, if you rule out implicit knowledge, well then indeed bisimulation implies a modal equivalence. And vice versa. So if you take the obvious restriction to image finite models, to models where in a given state there's only a finite number of successors, although the domains themselves may be infinite, then modal equivalence, well, corresponds to awareness by simulation. In what precise sense? Well, this stands for the notion, you might say, the standard bisimulation. This is a symbol for awareness bisimulation. So for the logic of explicit knowledge and for logic of speculative knowledge, where this means modal equivalence in explicit knowledge and this means modal equivalence in speculative knowledge, well, we have the correspondence between modal equivalence and bisimulation. If you go to the logic of implicit knowledge, where you can say things like this, well, then the correspondence is between the standard notion of bisimulation, where you do not do this intersection with all the variables an agent is aware of each time you do a next step. Then you have the correspondence of that notion of awareness with, well, this notion of modal equivalence. Okay, that's one result in the paper. How much more time do I have?
Well, you still have 7 minutes.
Okay, that's good. Yeah. We then, so you might say this is a correspondence result that relates logical equivalence to bisimulation. Then we have some results on the expressivity of these logics, where the main result is that there are two classes of expressivity here, and that the implicit knowledge operator is simply more expressive than merely the explicit knowledge operator, and that those are the two classes of interest. And a lot of rewrite rules to obtain further results. And what is somewhat harder to achieve in this setting is that the speculative knowledge operator and the explicit knowledge operator have the same logical power. This requires a more complex proof. But here I prefer to skip the results, and then there are some further classes below the logic of explicit knowledge that are of logical interest, but they do not really model intuitions about how an agent reasons. So it's good to complete the picture, but are not relevant to the application of reasoning about knowledge. Also, we looked at the axiomatizations of these logics. Well, the main thing to be said there, this has all been done by Joe Halpern already, and by the Fagan and Halpern original publications. So there we have a few footnotes to the results already reported there. And the addition we had was on the axiomatizations involving this notion of speculative knowledge, where I simply point out the differences in the axiomatizations. And so all the things that you do not see here, they are the same. And if you already, well, if you recall what they were like, you will then can conclude there's no difference here. But the difference is that the thing in the logic of explicit knowledge that is known that explicit knowledge implies awareness, and that we have some sort of adaptive necessitation rule that if you already have a derivation of phi, then on the assumption that phi is aware, you can indeed get that the agent explicitly knows phi. Well, in the logic of speculative knowledge, we actually have necessitation for that operator, because that operator can indeed reason about unaware variables, but we have a more complex rule how to get things from speculative knowledge. And that complex rule says that if you speculatively know something, then if you're unaware of a variable occurring in that formula, well, then you also speculatively know anything where you can replace that occurrence by any other formula. So it's indeed a wild card in your reasoning. Okay, final part of this presentation. Finally, let me get to the dynamics, at least the part that was also promised to be somewhat different in the setting of our approach from the already existent approaches in the logics of knowledge and awareness. Wasn't the original motivation how to get from the agent is uncertain about P to the agent is uncertain about P and uncertain about something else? For example, that's something else that came up in conversation because given unawareness of this wine thing, when someone mentions that wine and coffee will not both be served, to me, the agent being only uncertain about coffee at this moment, that announcement creates awareness of the issue of, is there wine after this talk, in my mind. And so this informative act makes me aware of another propositional variable and its possible value. But the main thing of this particular way of becoming aware of wine is that you are becoming aware of another variable Q in a way that already rules out some of the uncertainties about Q. Okay, so the morale of that becoming aware of a new variable does not automatically mean that you consider all possible combinations for that variable. It's more becoming aware of something new by clearing up the fog, after which you see more structure, but that is already there. But it's not like any structure could have been possible. Well, this structure is the structure that you become aware of. And I mentioned that we could model this by, well, making the red Q's black. In the sense of some swap, well, we have a distribution of aware and unaware variables in every state. So becoming aware is just making some unaware variables aware in some of these states. That's what's happening here. Well, that is one way to do this. I will not give the details of how to do this. And you can then say things like, well, before, well, on the left-hand side, the agent is unaware of variable Q. And after becoming aware of Q, the agent is aware of Q. Notice that I'm not saying this under the scope of anything about the agent I. I'm not saying that the agent knows that it's unaware of Q and that after becoming aware of Q. No, because you're not supposed to say that an agent explicitly knows something about the things he's unaware of. I'm merely saying that as an observer, I can report that the agent is unaware of Q, and after becoming aware of Q, then the agent is aware of Q. Okay, well, one way to model this then computationally is do this using the action model framework by Balta-Moss, and do this as an action model, and that would then be, it's like an announcement, this would then be a singleton action model. Yes? Why do I not put a K operator to bind this whole expression?
Why didn't you put the agent name?
I didn't put the agent name here because this has a notation of a sort of public announcement of awareness. So in the presence of more agents, it would also mean that the other agents also become aware of that Q. So if someone mentions that there is no wine and coffee served, that would also be intelligible to other agents except I. Okay, I'm trying to wind up here. There's also another way to model the agent becoming aware of new information Q, because after all, this implicit knowledge part of the framework of logic and knowledge is just, you might say, a theoretical contraption, but we really want to model explicit knowledge or epistemic notions already involving that awareness, right? Even in the course of the literature, you saw this involved. This implicit knowledge thing came later. So, and then in this other way of becoming aware of Q, then the complexity of the dynamics is put into the action, because this would require an action model of, well, that is not a singleton. Here I will skip the details. So relating to this, and this will be the final -1 minute indeed for my presentation here. So the results we achieved for this dynamics of knowledge and awareness are actually two. The first result is that, well, in the logics of knowledge, you have a result that any sort of informational change between two models can be achieved by executing a certain action model. Well, similarly, in this logic of knowledge and awareness, any sort of knowledge change or awareness change can get you the transformation of one state of knowledge and awareness to another state of knowledge and awareness, where becoming unaware is also an option, by the way. So this is incorporated in this framework. The other result here is that in the presence of dynamics, after all, the logic of explicit knowledge becomes equally expressive as the logic of implicit knowledge. Why is that? Well, that is for the simple reason that here we couldn't distinguish these structures in the logic of explicit knowledge, right? But Of course, once you are aware of P, then they are different in the logic. Well, even from the point of view of explicit knowledge, because the agent knows that here P is true and here P is false. But of course we can say that after becoming aware of P, the agent explicitly knows that he explicitly knows P. But this is something that you can say on the left-hand side. So once you add the dynamics, the logics become more expressive, but this increase of expressivity does not hold for the logic of implicit knowledge. So in the end, we have that they are equally expressive if you add dynamics, but they were not equally expressive before you add dynamics. Thank you very much.
One questions perhaps?
I got here. Speculative knowledge, how can it help with bisimulation? Because in Hector level paper, for all I know, I'm only knowing, but how can it help here for speculative knowledge in your case? Because I can't get to the point. How can I get? Because implicit knowledge is there, explicit knowledge is there. So, in speculative knowledge, how can it help this case exactly in bisimulation?
Well, if I have speculative knowledge, even on the left-hand side, I can reason about this P about which I'm unaware, right? But as a speculative reasoner, the moment as long as I'm unaware of P, I can still not express the difference between P being true there and P being false at the bottom. Because both is speculatively, I can speculate about both options. They are indistinguishable from me at this stage. So even though I can use P in my reasoning, I can still not make a difference between these two structures on the left-hand side. Whereas on the right-hand side, well, once you are aware of all the relevant variables, all these notions collapse to one notion. So then implicit, explicit, and speculative knowledge are all the same.